Hello and welcome back to the San Diego Convention Center for the 48th Design Automation Conference and our DAC 360 coverage sponsored by Cadence. I'm Brian Fuller, Editorial Director of E Times E Live section, and we're in the final sprint on the second of 3 days of live streaming from San Diego, California. And with us now is David Deharnais, Group Director of Product Marketing for Silicon Realization at Cadence, which is a mouthful.
It is a mouthful, I agree.
Welcome, David.
Thanks, appreciate it.
So, it is now 12 o'clock on day 2. If you count Sunday, if you weren't out running the marathon, it's probably day 3. What have you seen? I want to ask you, what you've seen, what's cool, then I want to dive into what you're doing at
Sure.
Cadence. So, anything strike your fancy at the 48th DAC?
Well, I think the emphasis seems to be around advanced node. I don't see so much emphasis on low power like we've seen in the past. I mean, it's everybody understands power, and it's a requirement. But I think 28 nanometer, 20 nanometer starting to become very interesting for customers and what they need to deal with in order to address the design requirements. I think that's been a lot of talk. 3D IC was a really big deal last year. So I see an attenuation of the visibility around it, but people understand that it's coming. So I think if I were to look at this DAC, I think the big things are around advanced node and how to prepare for it.
And by advanced node, you mean 28 and 20?
Yeah, 28 and 20. I mean, I think the fat part of the market, 65 and maybe even 90.
Right.
The bleeding edge customers are moving to 28 in a frenzy, and then now everybody's worried about 20.
Yeah.
20 is probably a lot of test chips happening right now, probably a couple of dozen test chips happening. 28 is now ramping up into production, a bunch of different flavors for that. And they felt a lot of pain at 28, and they look at 20 as another big inflection point. And so we've been very busy in our booth, specifically around 20. And some of the things that we have to do to prepare for that, it's not just even the advanced rules, it's about how big these bloody designs are, right? How do you cut this thing up? How do you maintain sanity as you go from silicon, package, and board? Right? Because ultimately, nobody ships this little tiny piece of silicon. They ship it in an end product. And in order for you to be compliant, in order for you to have a successful tape out with high volume, you got to have yield. You have to understand all of those elements, silicon, package, and board. And uniquely, this is something we provide from a Cadence portfolio, but it's something that everybody needs to deal with, one way, shape, or form.
Yeah, no doubt. So 28 nanometers is ramping IP, 60 to 75% of an SoC design.
Reuse, absolutely.
Reuse, hugely important. So you obviously have some bleeding edge customers who are at 28 with your tools. It's not just about, I can't imagine, it's not just about power and performance trade-offs anymore. It's a lot more.
Well, it's power, performance, and area. Those are going to be standards for sure. But it's, any design that's going to be 28 nanometer or below is going to have to target a very high volume application. So you're looking at consumer. So if you're looking at consumer, you're looking at a lot of real world analog to digital conversion, et cetera. You got high speed interfaces you have to worry about. A lot of companies aren't building them themselves. They're integrating. They're not creating, they're integrating. Right? They're integrating IP. So how do you model the IP? How do you abstract IP so you can have a higher level of visibility and do formal analysis and SoC level types of analysis and optimization? That's something that I see with specifically 28. It's the large chip sizes, it's the reuse that has to happen at those nodes, and it's accelerating for sure.
So there's a lot of IP that's now being sort of offered by the foundries, which makes a lot of sense because you're tied into those design roles. Is that kind of the end game for any sort of IP startup today, is to eventually kind of make its way into a foundry flow? Because there's so much complexity you have to do.
Well, there is. I mean, there's a lot of discussion right now about, should you only offer hard IP or synthesizable IP or that soft IP, right? And I think, the jury's still out on that. I mean, there's a lot of room to grow in terms of, a lot of IP vendors. I see consolidation of IP vendors. I see that there's a big focus on high-speed interfaces, but working with foundries, you have to, with double patterning as a reality at 20 nanometer. You have new devices coming in, FinFET devices or Tri-Gates, depending on who you're talking to. How do you put those in such a way that an end user can implement those cleanly? So I see more of a drive to offer multiple flavors for IP. So you have soft IP for the daring that want to implement it all themselves. There's some sort of hybrid model or a full-on hard IP. And I think more and more, the jury's still out on it, but I think more and more we'll see a lot of hard IP, getting plugged and played into these quickly assembled products that need to get to market.
Okay, so you guys launched Silicon Realization last year.
Yeah.
It's kind of a catchy phrase, but you can see the customers out here, the audience out here. You know, they're crusty, skeptical
Sure they are.
engineers, and they
And they should be.
and they're faced with something like realization. That's kind of a crunchy word.
Yeah, it's like holistic,
Exactly.
right? Or
Exactly.
solution.
Which, yes.
What the hell is that?
So in the Cadence vernacular, what does that mean?
So we introduced Silicon Realization, but in November of last year, right? And so we've been around for a while. I mean, Cadence is not a brand new company. Technology innovation doesn't stop though. And what we're finding our customers demanding more is not a point tool approach. I look around DAC and I see a lot of point tools. I see a lot of point tools which are necessary, right? But for productivity purposes, for cost reasons, we need to have an integrated flow. Silicon Realization is making a decided and deterministic path to silicon by saying, look, point tools are over. You have to be able to tie point tools together in a flow that a customer can use from silicon, package, and board fabrics in order to comprehend what you're going to end up with as an end product. So Silicon Realization for Cadence and for the industry is, how do I create a more predictable or more deterministic path to silicon? I need to understand this. And the way that we drive our product lines internally, and this is really the crux of it, because otherwise it's just a marketing name, right?
Yeah.
Is I refer to it as intent, abstraction, and convergence, these three pillars. Now design intent, I think you fundamentally understand. I mean, it's just, what am I trying to do? And if I'm at a system level design, like, I mean, EDA 360 in and of itself is flipping the equation upside down instead of saying, look, bottoms up designs are the way we've done things forever. Now we're talking about top down. Top down meaning application driven, which means you start at the system level. System level architecture, hardware, software, co-design, making trade-offs, pushing down into the SoC level, picking the right IP, and then ultimately down to what is Silicon Realization, which is my baby, which is about how do I create this IP. So when we look at intent, I have to understand the design intent from system level all the way down to that silicon implementation. Now that's design intent. Abstraction is another critical element of this. In abstraction, you think of it in two ways. You know, when you take something simple, we do this in driving, right? When you're driving, I bet you drive somewhere and you don't even realize what road you took, or you don't even remember passing sign. I mean, you've abstracted the problem, right? You can't 10 and 2 and drive wide eyes, with eyes wide open all the time, very vigilant. You just don't do that because it becomes comfortable. Mentally, intuitively, you just kind of abstract the problem. So we're used to that. When we eat cereal, we don't spoon in, up, eat, chew. You don't do that. It's just natural. You abstract the problem. It's just a natural extension. When we look at abstraction from a design implementation, right, is you got a lot of data. You have terabytes of data that you have to deal with. How do you optimize that in any sane way? You have to take modules, you have to block it out like IP, which is where IP reuse comes in. You have to block out pieces of it and abstract up a model that is accurate enough so you can do top level optimization that is accurate, that you can trust and believe in. So that's one kind of abstraction. Now we do that. The other kind of abstraction is just simply automation. The complexities we ask designers to go through in order to achieve a 28 or a 32 or now emerging at 20 is incredible. You have to automate this process because I don't care how smart your engineers are. It's a lot going on there that they have to deal with. And so we have to abstract the problem in a way that is automated, give them reference flows, not the kind of that you would see from a foundry, literally implementation flows that say, look, this is how you get good stuff out of the box. So that's abstraction, and the convergence I think you get. I mean, it's effectively taking downstream effects and putting them up earlier in the process so you make better decisions. So intent, abstraction, convergence is how we drive our product lines for Silicon Realization. And Brian, the other thing we did is we completely reorganized our company to line up with this. So it's not just a bunch of independent business units or a bunch of groups trying to fight their own battles on their own days. We recognize fundamentally, you've got to tie this stuff together. And that's what Silicon Realization does.
All right, well, I'll let you get back to your customers. David Deharnais from Cadence. Thanks so much for stopping by. I think I pronounced the name correctly twice.